Hello, welcome to the video of Simpson's and one-third rule and Muller's method in C program. So in here, we're going to use C language in implementing Simpson's one-third rule and Muller's method. So let's first start with Simpson's one-third rule. Simpson's one-third rule. Simpson's one-third rule is one of the formulas used to find the approximate value of a definite integral. A definite integral is an integral with lower and upper limits. Usually, to evaluate a definite integral, we first integrate using the integration techniques, and then we use the fundamental theorem of calculus to apply the limits. But sometimes we cannot apply any integration technique to solve an integral, and sometimes we do not have a specific function to integrate. Instead, we have some observed values in case of experiments of the function. In such cases, Simpson's one-third rule helps in approximating the value of the definite integral. So, Simpson's one-third rule formula. The formula is function of x dx within the limits of a to b is equal to h over 3 times fx0 plus 4 times fx1 plus 2 times fx2 up to 2 times fxn minus 2 plus 4 times fx1 minus 1 plus fxn. So the n is defined in the equation as an even number. So n is defined in the formula as an even number, which is the number of subintervals that the interval a, b should be divided into. N is usually mentioned in the problem. So x0 is equal to a and xn is equal to b. So a is the lower limit and b is the upper limit. So to find h, we use the formula h is equal to b minus a over n. So x0, x1, and x up to xn are the ends of the n subintervals. So scope and delimitation. So code blocks and C language is used for this project. The program will implement only Simpson's one-third rule to get the interval of a function. The program can only solve one defined function at x. The function to be solved must be manually typed into the program. Final answer is in 6 decimal places. Subinterval should be an even number. And lastly, the program will terminate after a successful run. Source code. So let's see the source code of the program. So this is the here. This is the source code of the program for Simpson's one-third rule. So these are the library or the preprocessor section. So head files help us to access others improve code into our code. So these are the used standard input output. So float, and here are the float f, float x. So in here, return. This is where we input the equation or the function at x that need to be evaluated. So these are the declarations here. These are declarations, the variables and the functions to be used in anywhere in the program. So it is where it asks the user to enter the values of x0, xn, and h. So this is the value for n and h. These are the if else statement in here. So these are the formulas for x and y. And this is the formula for the Simpsons one-third rule. So answer, the final answer is still defined here as answer a and s is equal to h over 3 times y0 plus yn plus 4 times so plus 2 times se. So let's try using this code. So before using that, let's know first the algorithm of Simpson's one-third rule in C program. So here, define the equation to be integrated. Manually input the equation f at x into the program. As the program gets executed, it asks for the value of the lower limit, which is xo, upper limit xn, and width of the strip, which is h. So the program finds the value of number of strip as n is equal to xn minus x0 over h and checks whether it is even or odd. If the value of n is odd, the program refines the value of h so that the value of n comes to be even. Calculates the value of f of x, y at different intermediate values of x and displays values of all immediate values of y. So here, the inputted values of x0 up to xn is then substituted to the f at x equation to get the values of y. So the values of y are displayed in the output of the program. So the program uses the function formula to calculate the value of integral in loop. So this is the formula. Integral is equal to y0 plus y1 plus 4y1 plus y3 plus y1 minus n plus 2 y2 plus y plus up to y1 minus 2. So finally, it prints the values of integral, which is stored as answer in the program. So sample problem. Solve for the integral of the function with limits from 0 to 6. So the function is the integral of sine x within the limits of 0 to 6. So let's use the C program to solve for this one. So here, let's input the f at x function. So the function is sine x. And let's build and run the program. So enter the value here. Enter the values of 0, 0, and of x0, xn, and h. So we're gonna input 0, 6, and 3. So these are the answers. So we find the output of the program is refined as value of n and h are 2 and 3. So the x values are 0, 0.141120, negative 0.279415, and the final integration is 0.285065. So let's the output of the program is this one. So after the execution of the program, we got these answers. So here is the final answer, 0.285065. So let's compare this final answer to the one or the template in Excel for Simpson's 1/3 rule. So in here, the x is 0 also, h is 3, same as this one, xn is 6, so it is given. The values of x are 0, 0, so it's the same, 0.14112, 0.14112. So y, negative, negative 0.279415, negative 279415, and finally the final answer 0.285065. So the output in Excel and the C program that we executed are the same. So this proves that the C language program is correct and tells the right answer. So let's go now to Miller's method. So here is the Miller's method. This method was first presented by B.E. Muller in 1956. This technique can be used for any root finding program, but it is particularly useful for approximating the roots of polynomials. Miller's method is an extension of the second method. The second method begins with two initial approximations, 0 and x1, and determines the next approximation, x2, as the intersection of the x-axis with the line through x0, fx0, and x1, fx1. So this is the second method. This is where the Miller's method derived from. So from the second method, these formulas are derived. So, but the Miller method uses three initial approximations which are x0, x1, x2, and determines the next approximation x3 by considering the intersection of x-axis with the parabola through x0, fx0, x1, fx1, and x2, fx2. So here are the formulas derived from the second method. So from the second method formulas, this the values of A, B, C are then derived. So B is equal to x0 minus x2 squared times fx1 minus fx2 minus x1 minus x2 squared times fx0 minus fx2 all over x0 minus x2 times x1 minus x2 times x0 minus x1. So for A, x0, x1 minus x2 times fx0 minus fx1 minus x0 minus x2 times fx1 minus fx2 all over x0 minus x2 times x1 minus x2 times x0 minus x1. So for C is equal to C is equal to fx2. So then x3 can be found easily by using the formulas that are used for calculating the roots of parabolas. The following lines explain this. So from here, this is now the formula for x3. So x3 is equal to x2 minus 2c all over negative b positive minus plus b square root of b squared minus 4ac. So b is determined if it is positive or negative from the given equation. So scope and delimitation. So code blocks and C language is also used for the project. The program will implement only Muller's method. The program can only solve one defined function. The function to be solved must be manually typed into the program. Final answer are in 4 decimal places. The program will terminate after a successful run. So here, source code. So this is the source code for the Miller's method for C programming. So these are the preprocessor section. Header files. This is inserted before the process of compilation. So float. So also define, and here you're gonna put the equation here to be evaluated. And these are the declarations. It asks the user to enter the initial guesses. Then here, allowed error and maximum iterations. So this is where the A, B, C are solved, as well as the X3. So if else statement, then let's try this program code. So let's try the sample problem in the program code. So find a root of an equation f at x is equal to cosine x minus x times e raised to x with the initial value of x is equal to -1, x1 0, x2 is equal to 1 using Miller's method. So execution of the program. Let's run this, build and run this program. So enter the three initial here. Enter the three initial guesses. So let's, according to the sample problem, the initial guesses are 0, -1, and 1. So here, enter allowed error and maximum iteration. So you can enter here the allowed iteration. So here I wanna try this 0.005 and maximum iterations. I'm gonna try 20. So here at iteration number 1, the value of x is 0.44157, at 2, 0.50647, at 3, 0.15762, at 4, 0.51776. So after the fourth iteration, the required root is 0.5187. So output of the program. So this is the output of the program, 0.1578. So let's compare the output of the of our C language program for Miller's method, the one computed manually. So coming up with this table. So same after 4 iterations, let's see if they have the same answers. So as you can see, the final answer is same, 0.5178. So here it is, 0.518. So this proves that the program is accurate and gives the same answer with the one computed manually. So this program saves time and make it easier for to compute those methods like Miller's and Simpson's method. So that ends the presentation, and thank you so much.